And we are back. I am Joe Amditis. I am Associate Director of the Center for Cooperative Media at Montclair State. This is Advanced Prompt Engineering for Journalists, and we are now starting video 1 of Module 3. So in our first module, we got familiar with using the command line. We poked around in the terminal a little bit and sort of brought ourselves out of the chat window on the internet and into the command prompt, which is a scary place for some of you, but I hope by now you've started to see the value in getting used to those new waters. In module 2, we really kicked it up into high gear to sort of show you exactly what these models are capable of when they have access to tools. And toward the end of Module 2, we also saw how you can take those really powerful workflows and turn them into skills and have the context and instructions and step-by-step plans injected into that conversation when it is relevant so that it's able to produce a more repeatable, more consistent, and structured approach to a common task that you often do. In this module, we're going to take it one step further because unlike before, sometimes you don't have time or you don't want to always have to load up the terminal or open PowerShell, point it at a folder and set it off on this monitored overview task where it's going to go through a huge list of things that you have to sit there and do. You want this to eventually sort of be automated. So you want to be able to set up a system where a trigger or some kind of event happens, and then that event itself is the kicking off or the jumping off point that triggers a preset automated workflow. And you want that to happen and be able to be triggered from the internet. You don't necessarily want to have to do this all locally. You want these things to connect to the internet and have scheduled cron jobs and all that. So today we're going to dive into that a little bit, and we're going to start by talking about some of the reasons why and use cases for this kind of system and where it might be most useful for you in your newsroom or various journalism tasks that you often perform. So as I said, our goal here is to go from I can do this once myself to this runs on its own. And this is where a lot of people sort of falter and stall. And if you're not a programmer, you often just hit a wall. This is something that maybe you've played around with something like Zapier or N8N, and these are all really good no-code trigger and response automation tools. And I would pause here and just remind you that if you have not explored basic automation and you're jumping right into generation, you may have missed a really crucial step. It's really important to step back and really understand and think in systems. You want to be thinking in conveyor belts, in splitters and mergers. If you've ever played Satisfactory or Minecraft or Factorio or any of these kind of systems architecture disguised as a fun game, and a very addicting game, I might add. I am a victim myself. Then you'll know what I'm talking about here. We need to be thinking of things in terms of resources and materials and the conveyor belts or lines that move them from a node where it is generated or where it's created or surfaced into machines or systems that transform them, combine them, split them, merge them, and then distribute them and their compound products to the destination where we need it. So things like emails coming in or receiving a particular flag or category tag. We're thinking of new spreadsheet rows in an Airtable database or in a Google Sheet. We're thinking of new files that get dumped into a Google Drive folder. We're thinking of all of these things. We're thinking of, messages or notifications that come over the internet into your various CMSs or databases. All of those kind of things, those are our inputs. And what we need to do is survey and gather those inputs, feed them into an automated system that in this case includes a CLI or terminal session of something like Claude Code or Codex. Codex or Claude Code does work on those materials. Those raw materials get put together and then they get pushed out to a variety of other destinations in the format and structure and style that you want, and that we can review and monitor that process as needed so that we get updates when errors occur or when backlogs happen. So that's what we're going to cover today, and we're going to jump in right now. So again, what an automation means here is that we have a script that runs a sequence of steps in a particular order. It happens the same way every time, and it handles reading the files, calling various APIs or MCPs, it formats the results, and then it saves the output. You are in charge of deciding what you want to build, what sources or nodes or inputs you're going to feed into this system, and designing the fallback mechanisms that will not just stop or have redundancies in place if an error occurs, but to actually catch those problems. And then you have to decide what happens next. Do these systems feed into each other? Are they a self-reinforcing feedback loop, or is it a sort of one and done kind of a thing? And throughout this entire thing, you're going to be applying that same thinking pattern of you are managing. You are not just prompting. You are organizing and setting up the infrastructure and the workspace, and the agent in this case is inhabiting that environment and using the tools that you've provided to do the tasks that you require. And the first step to this, the most important step here, is to plan before you build. And there are a variety of tools baked into any number of these CLI agents. Most of them go by plan mode. You saw in the last module a skill or a plugin called Superpowers that has a more expanded planning and design plan mode. Whatever you choose, you want to plan first. And the reason is you want to be able to see the outline of what you're building before you get a draft. You don't let somebody spend 3 hours on a draft without receiving or reviewing the pitch first. So don't let your AI bot or your agent spend minutes or hours on a script without understanding and reviewing and approving the architecture first. And you can do this in a number of ways. You can invoke the specific /plan command, but these models are often good enough where you can just kind of say like, hey, we need to plan out step by step an idea I have or a workflow that I'm proposing. And this is really important because the assumptions that you have in your mind and the way you think that this should work and envision it may be different from the assumptions that are baked into the model, depending on how you've set it up, depending on how you've set up your memory files and so forth. So catching those misunderstandings and those misaligned assumptions early in the process when it's just planning and just brainstorming is much, much better than catching it, way down the line when you've already wasted or burned tokens and time setting this thing up. And then you have to go back and refactor them. So in this case, we're going to be building a multi-stage pipeline. And that means that each stage of this process has one job. So at the beginning, you might have a fetch stage, something that brings in the files, puts them in a folder, grabs URLs, looks at RSS changes, or reviews new records that are added to a spreadsheet or a database. Next, we'll do a clean stage, which is going to do what it says. It's going to clean it. It's going to remove unnecessary noise or information, normalize the formatting, and structure the data so that it's easily readable by the script. Then we want to have a processing phase where the information is now clean, and now we're going to run it through our mill here to produce and combine and split and merge and all that to get the outputs that we want. And then at the final stage, we're going to document that, and we're going to log our progress and save it, write it to a file, update a spreadsheet, or send a notification. This can be in some processes the end of this workflow, but oftentimes you're going to be chaining these together. So, a new email comes in, you process it, you clean it, you process it, you save it, and then it gets added to a CRM or a task manager, a Kanban board. And then that process that's looking at the Kanban board picks that up and carries it and does something else with it. The point here is modularization. You should have these self-contained units of activity that have multi-stages within them, and each stage does its own thing. And the result and outputs of those can be repeatable and documented and saved and either fed into another system or repeated over and over again until you get the result that you want. And this is the kind of thing that is super important, especially as you continue or hope to scale up your systems. It is better to test on 5 workflows than it is to have to revert and error debug on 5,000. As always, we haven't talked enough, and we'll never talk enough about security and environment protections here and secrets. But it's very important to understand basic secret hygiene and basic internet and digital coding security. And I have resources on tools.mdis.tech and mooc.mdis.tech for this course specifically that talk about some good general hygiene best practices. But obviously up top, we never want to hard code any of our API keys or environmental variables in our code, especially if we're pushing them to GitHub. You can never do enough for security. You do want to make sure you're not falling into like the security psychosis patterns where you're so locked down because you're expecting like a CIA level penetration attack. but you also don't want to get have so much hubris that you think, oh, nobody cares about what I'm doing. Nobody would even bother to look at my sensitive data. Somebody will, and somebody does always. So that can be everything from making sure that you don't commit hard-coded values to the model itself. You can also ask Claude or Gemini or Codex to audit its own code to make sure hard-coded secrets are not in there. GitHub Copilot is actually surprisingly really good at catching these kinds of things, even some of the lesser known issues. And this is a really quick process, even just a quick spot check. It can take 30 seconds. It saves you from looking like an idiot and a novice, and it could save you some money. I've made this classic mistake. My early OpenAI API key was on GitHub very quickly. It got scooped up, and I woke up to a $50 hard limit API cost, charge hit, and I had to explain that to my boss, which was very fun. But that is a good way to learn that lesson, if you can make sure that at least I had my spend limits set. So there are a whole range of things you can do to set backstops to prevent that from happening. You can't be perfect, but you can be proactive. So before we jump out into the terminal again, we show this in the sort of real world here. We have our 3 rules. We always want to stage and plan our pipeline. We want to make sure we have separate stages broken down into separate steps, and each step or each phase has one job or one task that it focuses on. Then we segment that in, and then we move on to the next step. Number 2, we want to test small. We want to verify that before we spend all the time building up this whole complex pipeline, that the individual pieces work and each stage does what we expect it to do. And then for the love of God, we want to make sure we don't put our secrets in our code. You may have heard people talking about this before. They'll probably continue talking about it. They're right. They're right. They're right. They're always right. And the minute you mess up and you realize how right they are, you will wish you listened better at the beginning.